Good morning. Stone is a regularly used construction material, as we have seen yesterday. At different stages of construction has different components. Stones ranging from sizes of 80 to 20 to even up to baby metal for surfacing are employed in road constructions. Kilometers of stretch of roads of water-bound macadam roads and even bituminous bound macadam, bituminous concrete roads. In all these things, stones are highly employed. Stone is having very quite high value of compressive strength. We have seen told yesterday. Another important property of stone, mechanical property, is the resistance against crushing value. Crushing strength and crushing value are different. Crushing value means when the road surface is finished, when the vehicles are plying over the road, when the load comes on the road surface, it will be transferred to the components having stones bound together. So, how far when the load, the dynamic load, vehicles are moving with high tandem wheel loads, at that time, the resistance to powdering, that is what is called the crushing value. There are experiments for that using compression testing machine. If you have different sieves, a particular amount of aggregate will be put and it will be subjected to a specific load. Then after applying that load, it will be taken and sieved through another sieve. And if the residue, the thing sieved through, the material sieved through is more, its crushing value is less. That's a qualitative principle. Crushing strength is the resistance against compressive loads. Then the hardness of the stone. Hardness, when you have stone pavings, suppose the wheels are running on that or people are walking over that, it should have sufficient weathering resistance, mechanical weathering resistance. Resistance against mechanical weathering. Mechanical weathering is called abrasion. ABRASION, abrasion. So resistance against abrasion. These are the mechanical properties. Stone is a brittle material. So it cannot take more tensile stress. Stone cannot be used for members which is spanning a large length without making it strong in tension to by some external means, by using some other material which is capable of taking tension. Without that, stones cannot be used because they are brittle in nature and their tensile load taking capacity is less. So a stone, usually the first framed structure is a post and lintel construction. Post and lintel. It is a frame, a portal frame. Two stone pieces over which you will have a small horizontal lintel. That is also stone. Two stone columns and a stone beam. But the span will be very less. Suppose you have more span, then you have in between stone pieces. Because a stone, once it sags, one part of the bottom part of the stone slab will be subjected to tensile force, and the top part will be subjected to compressive force. But the compressive force it can take, but the tensile stress it cannot take, so it will fail. This post and pillar construction was used. You can see even now there may be monuments. There may be they may be telling the history when you walk along village or rural roads. These posts and the lintel were facilitating people who are carrying loads on their back, on shoulders and back, on head. So when they carry this along the road, just to take some rest, they just keep this on the lintel. If they keep it on the floor, ground, then lifting that and again putting will be very difficult. So around the chest level or at the shoulder level, maximum, you will have the post and lintel. So you can keep the load on that, take rest, again without any external help, you can take it back and proceed. For which stones were used, but the span will be very less. So stone is poor in tension, very strong in compression, it has satisfactory hardness. There are stones which have good aggregate crushing value and poor aggregate crushing value. For road construction, the aggregate crushing value should be more. More in the sense, it should have the powdering resistance less. Aggregate crushing value is better. If you tell in percentage, that percentage will be less. It has to be less for road constructions. The powdering phenomenon should be less in the case of road. You can tolerate a little more in the case of buildings, if the aggregates are used for buildings, because buildings usually are not subjected to dynamic loading. Speed, dynamic loading are there in road. So aggregate crushing value, it is not safe. If the aggregate, where the aggregate is employed, whether it is for the road or whether it is for the building, decides its aggregate crushing value. Then the bulk density. Another bulk density is a physical property. Any material has three properties. One is the physical property, another is the chemical property, and third is the mechanical or engineering property. Mechanical or engineering property. Mechanical and engineering property very much depends on its physical properties too. Bulk density is a physical property. Mass density is nothing but the weight of the material per unit volume. W by V, where W is the weight, V is the volume. Bulk density. When the bulk density is more, possibly the compressive strength will be more. Then as you know, the fundamental specific gravity is a physical property. Density, specific gravity. Weight in air by loss of weight in water. That's specific gravity. Then you have bulking. That bulking is not for aggregates. Aggregates or M sand, if you take bulking will not be there. But if you take sand, either the coarse sand or fine sand, bulking is a phenomenon where because of the apparent tension developed because of water particles, when you pour water to the sand, till it gets saturated. You just go on adding water to the fine sand or coarse sand. Their apparent volume will be more than the actual volume. This phenomenon will go on increasing till a particular value, till a particular moisture content in the soil. Then it will start reducing. So you have to decide the maximum percentage of bulking, that moisture content, at what percentage maximum bulking takes place. So if you really take some sand for some work, it will have some moisture content in it. So if you just measure in volume, the process of measuring is called batching. Process of measuring is called batching. So if you measure by volume, the actual volume of sand will be something less because it has been subjected to bulking. So usually people prefer to avoid this weight batching instead of volume batching. In the case of weight, this will not happen because you know the weight. So in weight batching is preferred to volume batching. You have different types of stones. I told you the siliceous, argillaceous, calcareous, igneous, sedimentary, metamorphic, granular, and I told you layered. The layered stone is the stratification. They are the stratification. Stratified rock and unstratified rocks. Then natural origin. Then semi-natural origin. Artificial origin. Accordingly, the stones are. Then there's a briefing of the stones. The next important material which is used is the brick, natural brick. The natural brick is laterite. Laterite is a natural brick. You get it from by cutting. It is a process of carving again, but it is cutting. You just using a chisel, proper chisel. There are skilled people who will cut from the laterite mountain, laterite blocks, specific sizes. Usually they will be square in size. Their plan dimension will be the same with a thickness from 4 inches to 6 inches. Thickness 4 inches to 6 inches, having dimension of maximum of 30 by 30, 1 foot by 1 foot, half of a foot thickness. Laterite. Whenever the laterite crosses its age, it is more seasoned. The water content inside it will be very less. It would have become dry and voids will be very less. It will be more denser and its bulk density will be more. So older laterite, old mountains of laterite will be better than the newly formed laterite quarries. But laterite is not a material which is available all over. There are specific areas, specific locations in particular states or country where you have this laterite. But if you start using the laterite on other places, the transportation will increase the cost. Then the brick is a semi-natural material. Brick. Brick is predominantly a ceramic material having clay. So you can say brick is an argillaceous to ceramic material. It will have sufficient, either it will have imbibed sand or you may have to add little sand. Silice, sand, silt, certain amount of silt. Alumina is predominant. Then you will have small amount of iron that imparts color to the brick. Iron oxide, FeO, that imparts color to the brick. So you get the clay not very much having silt or sand, more clayey. You have to prepare that clay before the next process known as molding. So suppose you have a land where clay strata is there below the topsoil. First the topsoil will be removed. All debris will be removed, grass will be removed, topsoil, say around 10 centimeter, it will be removed. Then you get the clay strata. Then you dig out. The process of digging out in construction is known as excavation. Excavation. We'll continue by God's grace tomorrow. Thank you.